Now let me explain some hidden concepts in this topic. Here, relation between the intensity of light I and the amplitude of the light. The intensity of light is directly proportional to the square of the amplitude, or we can write I equals to constant into square of the amplitude. Okay. Now let me explain the relation between the path difference and phase difference. Let the path difference is denoted by x and phase difference is denoted by phi. From this figure we can see that it is 0, pi and 2 pi. This is a sine wave 0, 180 degree to 360 degree. Okay. Then this is the wavelength. Here we can see that a path difference of lambda is equivalent to a phase difference of 2 pi. Also, a path difference of x is equal to a phase difference of phi. Dividing these equations 1 by 2, lambda by x equals to 2 pi by phi. Then we can write cross multiplying phi equals to 2 pi by lambda into x. This is the relation between phase difference and path difference. Okay. Now this formula sine A plus B, this is also important. Sine A plus B is sine A cos B plus cos A sine B. You learn it in mathematics, and also in class 10 mathematics you have sine square theta plus cos square theta equals to 1. And one more important concept is cos curve. The curve of both sine and cos is pulsating between +1 and -1. The value of sine theta and cos theta is between +1 and -1. Suppose this is cos theta and this is theta. Let it be 0, pi, +1, -1. Pi 0, pi or pi by 2, pi 3 pi by 2, 2 pi, pi 2 pi, 3 pi, 4 pi, 5 pi. Okay, cos starts from +1 and it is 0 at 90 degree, and it is -1 at this point, +1 at this point, -1, +1, -1, okay, 0. It is pulsating like this. This is cos curve. This is pi, this is 2 pi, this is 3 pi, this is 4 pi, and this is 5 pi. When theta is 0, 2 pi, 4 pi, and 6 pi, okay, cos theta is 1. Or we can say that cos theta is +1 when theta is 0, 2 pi, 4 pi, 6 pi, and so on. It means these are the even multiple of pi. We can write 2n is even number. okay, even multiple of pi, where n is 0, 1, 2, 3. Cos theta is minus 1 when theta equals to what? Minus 1 when pi, okay, 3 pi and 5 pi, also 7 pi. They are what multiple of pi? What number is denoted by 2n plus 1, where n is an integer. What multiple of pi? So n is 0, 1, 2, 3 again. Cos theta is minus 1 when theta is odd multiple of pi. Now I'm going to start explaining the conditions for constructive and destructive interference. Here we have a monochromatic source of light. These two are the slits. They act as the source for the screen. This is the screen. P is an arbitrary point on the screen on which we are going to determine whether it is constructive or destructive. Let us consider the two waves given by y1 equals to a1 sine omega t and y2 equals to a2 sine omega t plus phi, where a1 and a2 are the amplitudes of the two waves and phi is the phase difference between the two waves. It will be a constant phase, means phi is a constant phase difference. According to the superposition principle, we have y is y1 plus y2, so it will be a1 sine omega t plus this one, a1 sine omega t plus a2 sine omega t plus phi. Here we have sine a plus b. It is sine a cos b plus cos a sine b. It is a1 sine omega t plus a2 sine a cos b plus cos a sine b. Here a2 is common, we multiply both the terms. From the first two terms, we have sine omega t constant. So sine omega t or a1, sine omega t is common, a1 plus a2 cos phi plus from this, okay, now let us rearrange like this, cos omega t a2 sine phi. The term in the bracket, inside the bracket, is constant for both the terms. So we can replace these two constant with another constant, any other constant. We choose this side cos theta, cos term, and this side sine term to be sine a cos b and cos a sine b. This will be cos. Okay. It will be a sine omega t. This is the constant, another constant. Okay, let me write it here. A cos theta. We replace this with a cos theta, another constant, plus cos omega t. It will be a sine theta. If we write a here, taking a as common, we can write like this: sine a cos b plus cos a sine b. It is sine a plus b, so we can write a sine a plus b. this is the expression for the resultant wave. So we can write the resultant as a function of sine having amplitude capital A and phase difference phi theta with the first phase, the first wave. Okay. We consider that A cos theta is this term. Okay. A cos theta is equal to A1 plus A2 cos phi, and A sin theta equals to A2 sin phi. Sin theta, no, sin phi. A2 sin phi. Okay. And the resultant wave was y equals to A sine omega t plus theta. It means A is the amplitude of the resultant wave. We want to know A. Okay. A will give the intensity because the square of A is proportional to the intensity of the light, the intensity of the resultant. When A will be maximum, I will be maximum. Here we are going to calculate the value of A from these two. Squaring both sides and adding, we have A square cos square theta plus A square sin square theta, and this term, the square of this A plus B holding square, it will be A1 square plus A2 square cos square theta plus 2AB, it will be A1 A2 cos phi plus the square of this, it will be A2 square sin square phi. Okay, and taking these two together, A1 square plus A2 square sin square phi plus cos square phi. Okay, this will become 1 plus 2A1 A2 cos phi. We have A1 square plus A2 square plus 2A1 A2 cos phi. It is this, and on all the left side also A square cos square theta plus A square sin square theta, taking A as constant, A square as constant, cos square theta plus sin square theta, it will be A square. We have A square is this. We know that I is directly proportional to A square. For simplicity, we can replace A square with I. Actually, it is Ka square. A square is I by K. For simplicity, let us choose K as 1. A square will be I. Let us replace A square with I. The intensity equals to A square plus A1 square plus A2 square plus 2A1 A2 cos phi. It depends on phi, the phase difference. Okay. Since A1 A2 are the amplitude, they cannot be changed for the given lights. It is clear that the value of I is maximum when cos theta is maximum, and I is minimum when cos phi is minimum. I is maximum when cos phi is maximum. I is minimum when cos phi is minimum. The maximum value, first one, constructive interference. Constructive interference. Constructive means maximum intensity. I is maximum when cos phi is 1. It means cos phi is plus 1. Cos phi is plus 1 when phi is equal to even multiple of pi, where n is 0, 1, 2, and so on. Explained in the in this topic. And destructive, before that, the relation between phi, phase difference, and path difference. Okay, here this is the phase difference. It is equal to what? Phase difference is equal to, in the explanation we have, phase difference is 2 pi by lambda into path difference. So 2n pi. Then we get path difference is 2 pi, x equals to n lambda. Or it can be written as 2n lambda by 2. It means we will get maximum intensity when the path difference is even multiple of lambda by 2 or n lambda. Okay, this is for constructive interference. For destructive interference, cos theta value will be minus 1. Cos phi value is minus 1. Destructive. For destructive interference, cos phi is minus 1. So phi is what? Odd multiple of pi, where n is 0, 1, 2, integer. Then we get minimum intensity when phi is this much, and we know that phi is equal to 2 pi by lambda into path difference x. So 2n plus 1 pi. Then what will be x? Pi and pi cancel. X is 2n plus 1 into lambda by 2. Odd multiple of lambda by 2. Okay. When the path difference between the two lines, path difference means, I forgot to explain. Path difference is the difference between S1p and S2p. It is S2p minus S1p, the difference between these two lengths. When path difference is equal to odd multiple of lambda by 2, we will get destructive interference. When the path difference is even multiple of lambda by 2 at this point, it means we will get maximum intensity at this point. If we get like this, we will get minimum intensity at this point. Maximum intensity are called bright fringe, minimum intensity are called dark fringe. Okay. Constructive, maximum intensity, bright fringe, they are same. And destructive interference, dark fringe, and minimum intensity, they are same.